that was 5 minutes. That was 5 minutes. Okay, let's go over what our answers are for this. Now that I put my pen away. All right, so let's see. 8 times 3. 10 times 1,000. 10,000. 10 times 10,000.
100,000.
Oh, yeah, 100,000.
Yeah, 100.
How do I know that? Do I just add another 0? Yes. Okay? If I'm multiplying 10 by 1,000, I just need to add one more 0, and I know it's 10,000. So if I have 10 times 100 times 10,000, I add another 0, and so now I have 100,000. Okay? All right? Good? Good, good? All right, let's move on. All right, and next week. Because I want you to do well on the district assessment. Okay, all right, we're going to have a little guitar strumming going on here, I guess. Okay, again, let's look at our learning targets. All right, who would like to read the first one? Okay, Kate. Number 1.
Let's look at products that are decimals.
Okay, let's look at products that are decimals. What's a product? Quick, what's a product? Everybody.
Something kind.
It's the answer to what kind of problem?
Multiplication.
Okay, everybody say that together. A product means multiplication. A product means multiplication. Say it again. A product means multiplication. All right. Number 2, what's the second one? Let's look at some ways we can represent multiplication of decimals. Okay, nice job. These are the same learning targets we had the other day. We're just continuing with them today. All right, so when do we ever use decimals? Excuse me. Eder, I'm asking a question to the class. I want you to think about this for a minute and write an answer to one of these on the whiteboard. Think about it. How does multiplying decimals help us shop for clothes? When cooking and baking? With sports statistics? Answer one of those 3 on your whiteboard. This is a whiteboard. It's this whiteboard. Why didn't you go get mine? Right over here.
Shop for clothes.
Shop for clothes isn't an answer.
What about
It's a question. It's the question.
I didn't see it. It's just that I'm blind. What about this one?
Okay, so I'm going to come around the room. Everybody hold up your board so each other can see them. All right, so we have Maria. By knowing how much we need to use in baking and cooking. Yes. Okay.
What about this? How was the 15 and 5? What even is that?
Why?
No, I didn't.
Nemesis, you have something. No. Okay.
No.
What about cooking and baking? How does decimals help us with cooking and baking? By measuring. Okay. Thanks. Andy, what do you have? Measurement. Kate. All right. And Genesis? Okay, thank you. All right, so Tali. It can help you with baking, cooking, And knowing how much to add, yes. Bell. To see how much money in total we have to spend, yes, that would help us shopping. And Eder, to make food, buying food. Genesis R, what do you have? What? I can't hear you. Hold up your board.
What you say?
I erased it.
No, he doesn't lose it.
Eating food, how is that? How do you think that's how it helps you know how much to use in cooking food. A partner, or the people at your table, some of you are just 3 people, you can work together. You're going to select all the expressions that are equivalent. What does equivalent mean? If something is equivalent, the same, it's equal. All right? So select all the expressions that are equivalent to 6/10 times 5/10. Be prepared to explain your reasoning, and I will be randomly calling on people with our handy dandy random name caller. Yeah. So write the letter on your whiteboard of which ones we have A, B, C, D, E, F, G. Which ones you and your partner agree equal 6/10 times 5/10. And be prepared to explain. And then how much does that actually equal when I multiply those together? All right, you have 10 minutes. That's a lot of time. And you are working with your partners. Okay, the timer is on. Which ones are equivalent? You write the answer in your book, but also Norma, which one of these do you think is equivalent? F? All right, let's see. We have 6 times 5, so we have both of those numbers, 6 times 5. And then we have 1/10 times 1/10. This is 6/10 and 5/10. So, yes. Okay, that one is equivalent. I just moved my whole board. All right, so Norma, that was great. Okay, that was correct. Okay, Melanie volunteered an answer. A. Is A look a lot like F? Yes. We have 6 times 1/10 and 5 times 1/10. 6 times 5 times 1/10 times 1/10. Any other answers here? Does anybody else want to volunteer? C. C, yes. What else? And G, yes. If you did not have those, mark them in your book right now. Which expression does not belong? A. You need to look at the board or at your book. We have 4 expressions. Which one does not belong? C, C, C. A. Lots of C's. A. Come on, I need an answer. A. C. C. A. Wow, we're about half and half on observation. I actually made that observation. So every other number, and I should stop. has 1 10, and A has 3 10s. Okay, and then for someone who chose C, Orlando, you had your hand up. You had your board up. Eder, why did you choose C? Is there another reason that half the class chose C? Kate, what'd you pick? Why? What looked different about C to you from the other ones?
It's just that all of the numbers are wait, and then like the other numbers are
Okay. And Maria, what were you going to say?
I was gonna say the same thing.
Okay. All right, well, if you look at this number here, we have 2 times 3 tenths. So this is 2 times 3. That would give us 6, right? 6 times 1 tenth. 6 times 1 tenth. 6 times 1 tenth. All right? I got you, Carlos. I got you. Okay. All right. Let me come back here. Okay, let's do this problem. And then we're going to play a game.
Yeah!
We're going to look at this problem right here. This should be on, I think, the next page. Let me see real quick what page we're on. Okay, page 158. 158. 158. All right, so what you're going to do on this page, we have 2 different, okay? We have 2 different methods for solving the equation 2300 times 1 5/10. This is Elena's method. This is Noah's method. If we look at this real quick, what did Elena do? What calculation is she using? Okay, look up here. What are they doing that's different?
One of them is multiplying and the other is like making it into a decimal instead of making it into a fraction.
Is it, well,
Converting it
turning the decimal into what?
like a fraction.
Yes, okay, and using fractions.
Ms. Dawn, can I have Genesis?
Which one?
Andrew?
I have Genesis Madrano, Genesis, she's not here.
Not here, okay.
Alright. Okay, so using fractions, and if we're using fractions, what does that bar mean? What does, if I write 23, just to make it bigger, what does that mean? Yeah. 23, what do we divide? Alright, so Elena's multiplying, Noah is dividing. Okay, this is what you're going to do.
I always wanted a brother.
You're going to work with the people at your table. I'm giving you some directions. You're going to work with the people at your table. Analyze the two methods, then discuss these questions with your partner. Which blanks method makes more sense because? Do you think Elena's method makes more sense or Noah's method? Okay, so which method makes more sense to you and why? And then what might Elena do to compute this other number? Okay? What might Elena do to come up with that answer? Will the two methods result in the same value?
The last one to finish has to take a shower.
Carlos, would like to answer this. Whose method made more sense to you?
Yes, yes, I don't know.
It's not funny after a while. Okay, Jamie, we have Elena doing multiplication, and we have Noah using fractions, which is doing division. To you, which one makes more sense? Which would be easier? They're both correct. Elena's? Okay, whoops. Why do I keep moving that around? Oops. Okay, so Jamie says that Elena's method makes more sense to her. Okay, because she's multiplying and that's easier for her to see. I know that Emma had a different answer. Emma, what was your response? Maria. Okay, so Emma thought Noah's method was easier or made more sense. And why was that?
Because the method you actually multiply by 100.
Okay, because we turned 2300ths into a fraction, and we turned 1 5/10 into a fraction, and then it was easier to divide. Now we can multiply both sides, the denominator and the numerator. And that helps us come up with our new decimal. Do that for a second. Okay, so while we're paused right here, get your Chromebooks out. Hands up, Crypto Hack. Hands up, Gold Quest.
I have negative, bro.
All right, it's on.
Look. If our winner is like Roberto Carlos.
Okay, took 10 gold from Roberto. Norma just took 4 from Roberto. Dennis and Dee just took 6. Uh-oh.
And look at the name.
What is that? Who is this person?
I don't know. Bro. What? I know. Who is Belly? I'm gonna sue whoever.
Whoever has that name, remove yourself from the game.
What's the name?
Well, I can't get to them right now.
What? Nick! Yo, bro, what? Night. Why does everybody have 0?
All right.
Why do I keep getting the answer? Why do I have 0? Let's go. That is racist. I wonder why.
It is.
That's racist. Oh, wait, why did you put that? Bro, that's actually so disrespectful, bro.
Would you want to put that away? Put that stuff away. Right?
Joel, you know what you should do? You should put everybody's screen and it says their name
not here anymore.
Liz, can I go now? Oh snap.
Oh, snack, I know.